Now the next topic, that is motion in a magnetic field. Now see, we already discussed this thing. When any charge Q is moving with velocity V in magnetic field B, then the force acts on it, that is given by the equation Q into V cross B. Now here from this equation we can say this thing, the force acting on that charge, that is perpendicular to both velocity of the charge and the magnetic field. Okay. Now, when force is perpendicular to the velocity, so in that particular case, in standard 11th, we studied this thing. The motion of the particle, that will be circular one. And now here, as shown in this figure, if we consider the magnetic field which is perpendicular to the plane of paper and going inside, then in this particular uniform magnetic field B, if a charged particle enter with velocity V, velocity of the charged particle, that is in the plane of the paper. Now here the force acts on charged particle, that is perpendicular to the velocity, so that charged particle in this magnetic field executes circular motion, and to sustain its circular motion, the required centripetal force, that is provided by this magnetic force. Now, for any particle having mass m moving with speed v on the circular path having radius r, the required centripetal force, that is mv square upon r. And this required centripetal force will be provided by the magnetic force. So magnitude wise, this magnetic force, that is qvb sine theta. But v and b are also perpendicular here. So theta is 90 sine 91. So we can write here the magnetic force magnitude wise, that is qvb. We cancelled here. So we can write the equation for the radius of the circular path of this charged particle, that is mv upon qb. mv, that is the momentum of the particle. So we can write r, that is equal to p upon qb also. Now here we can observe this thing, r proportional to momentum. Means if the momentum of the particle increases, then radius of its circular path also increases. Clear up to this one? Now, in this equation of the radius of its circular path r equal to mv upon qb, replace v by r omega, where omega, that is its angular frequency. So we can write r, that is m into r omega upon qb. So omega, that is qb upon m. So this is the equation for the angular frequency of the charged particle executing circular motion here. But omega, that is 2 pi f. So we can write 2 pi f, that is qb upon fm. So f, that is equal to qb upon 2 pi m. So from this one, we can write the period for its revolution t, that is equal to 1 upon f, that is 2 pi m upon qb. But see here, these equations which we discussed, in that we can conclude like this. The radius of the circular path, that depends on the momentum. Or we can say radius of the circular path, that depends on the speed. If speed increase or decrease, then corresponding to that, the radius also increase or decrease respectively. But see, angular frequency QB upon M, constant one. The frequency F, that is QB upon 2 pi M, it is also constant. So T, that is constant one. So in this way, we can say this thing, or we can conclude like this: when any charge particle enter in the magnetic field, uniform magnetic field B, with velocity v perpendicular to field, then it executes the circular motion in the magnetic field with circular path of radius r equal to mv upon qb, and the angular frequency, or the frequency for the revolution of this particular charge particle, that remains constant one here. And that constant angular frequency or frequency are given by these equations. Clear to all of you? Now see, in previous theory we discussed this thing: the velocity of the charge particle is perpendicular to the magnetic field. But suppose the velocity of the charge particle is at some angle theta with respect to the magnetic field. See the figure. Suppose, as shown in the figure, the uniform magnetic field that is in x direction, and a charge particle enters in this magnetic field with velocity v at some angle theta with respect to magnetic field B. Then here we have to take two components of velocity v. One component that we have to take parallel to the magnetic field, or we can say in the direction of the magnetic field, and another component that we have to take perpendicular to the magnetic field. Now, we already discussed this thing. If velocity is parallel to the magnetic field, then force will be 0. So here we can write this thing: in the direction of the magnetic field, if the velocity component, that is this v parallel, then force due to this velocity f parallel, that will be equal to 0. So we can say this thing: this charge particle will move in the direction of magnetic field with constant velocity v parallel, because in the direction of magnetic field the force is 0. But if we consider this component v perpendicular of the velocity, which is perpendicular to the magnetic field, then in previous theory we already discussed this thing: if velocity and magnetic field are perpendicular, then particle will execute the circular motion. Now here, in this particular case, particle is executing circular motion under the effect of the magnetic force, as well as it also executes the translation motion in the direction of the magnetic field with constant velocity, this v parallel. Therefore, resultantly, the motion of the particle, that will be on the helical path. And now if we take the radius of the circular path, then that will be given by the same equation mv upon qb. But here we have to take this velocity which is perpendicular to b, so that is this component. And if this angle is theta, then this v perpendicular component, that we can represent by v sine theta. So radius for the circular path of the particle in this case, or we can say radius of this helix that is given by mv sine theta upon qb. Now, when this particle complete one revolution in the magnetic field, during that revolution, it will be translated in the direction of the field, because in the direction of the field there is no force. So it is moving with constant velocity v parallel. So some horizontal distance is traveled by it. So the distance traveled in the horizontal direction during one revolution, that is called pitch. That is called pitch. So we can write the equation of the pitch P, that is equal to velocity into time velocity, that is v parallel, and time taken to complete one revolution, that is the periodic time. So v parallel, that is v cos theta, periodic time, that is 2 pi m upon qb. In the previous theory we derived this equation. So resultantly we can give the equation of pitch, that is 2 pi m v cos theta upon qb. Clear to all of you up to this one? And the angular frequency and the frequency and periodic time we can give by the same equations which we discussed in the previous theory. So angular frequency omega, that is qb upon m, frequency f, that is qb upon 2 pi m, and period of its revolution, that is t equal to 2 pi m upon qb. Frequency that we also represent by the symbol nu. Clear to all of you? Now example 4.3. What is the radius of the path of an electron? Mass, that is 9 into 10 raised to minus 31 kilogram, and charge, that is 1.6 into 10 raised to minus 19 coulomb. Moving at a speed of 3 into 10 raised to 7 meter per second in a magnetic field of 6 into 10 raised to minus 4 Tesla perpendicular to it. What is its frequency? Calculates its energy in keV. Now see, mass of the electron 9 into 10 raised to minus 31 kilogram, charge of electron, that is 1.6 into 10 raised to minus 19 coulomb, speed with which it is moving, that is 3 into 10 raised to 7 meter per second, and the magnetic field B, that is equal to 6 into 10 raised to minus 4 Tesla, that is given to you. Okay. Now radius of the circular path R, that is mv upon qb. So mass m, that is 9 into 10 raised to minus 31 kilogram. Speed v, that is 3 into 10 raised to 7. Q, that is 1.6 into 10 raised to minus 19. And B, that is 6 into 10 raised to minus 4. Solve this one, you will get the radius of its circular path. Then to calculate the frequency, we can use the equation F equal to QB upon 2 pi M. See, from this equation of the radius, you can write QB upon M, that is V by R also. So you can use the equation V upon 2 pi R also, right? Now in the equation F equal to QB upon 2 pi M, substitute Q, that is 1.6 into 10 raised to minus 19. B, that is 6 into 10 raised to minus 4, 2 pi and mass that is 9 into 10 raised to minus 31. Solve this one, you will get the answer. Then its kinetic energy, that is half mv square. So half mass is given to you, 9 into 10 raised to minus 31. Speed 3 into 10 raised to 7. Take square of it. Solve this one. You will get energy in terms of joule. But you have to calculate it in terms of electron volt. So divide this answer in terms of joule by 1.6 into 10 raised to minus 19. And you will get energy in electron volt. Clear? Now the next topic, that is motion in combined electric and magnetic fields. Velocity selector. This is the special case. Now see here. Suppose we have the electric field and magnetic field. Both are perpendicular to each other. And a charged particle enters in both the fields perpendicular to both fields. It implies that now electric field, magnetic field, and the velocity of charged particle, all these three are mutually perpendicular to each other. See the figure. Suppose, as shown in the figure, the velocity of the charged particle is in x direction, electric field that is in y direction, and magnetic field that is in z direction. So we already discussed, in the presence of electric and magnetic field both, the force acts on charged particle, that is the Lorentz force, and that is given by F equal to Q into E plus V cross B. So we can write QE plus Q into V cross B. QE, that is the electric force, and Q into V cross B, that is magnetic force. Now electric force, which is QE. So Q, that is the scalar quantity, E, that is vector quantity. So the direction of the force, that will be in the direction of electric field. And in our case, at present, electric field that is in y direction. It implies that the force due to electric field on this charged particle will be in positive y direction. Now magnetic force, that is Q into V cross B. V, that is in x direction, so Vi caret. B, that is in z direction, so Bk caret. So magnetic force, that is QVB into I cross K. But I cross K, that is minus J. So minus J represents negative y direction. It implies that here the magnetic force, that is in negative y direction. So when electric field, magnetic field, and the velocity of the charged particle, all these three are mutually perpendicular, at that time the electric force and magnetic force acts on the particle are mutually opposite. Now see here, suppose we consider the magnitude of these two forces, that is equal. Suppose magnitude of these two forces, that is equal. So in that particular case, the net force on the charged particle will be 0, and the charged particle will move with constant velocity. So what will be that velocity? So if magnitude wise electric force and magnetic force are same, then we can write QVB, the magnitude of magnetic force, that is equal to QE, the magnitude of electric force. Q cancelled. So V, that is equal to E upon B. So if electric and magnetic field are mutually perpendicular, and if charge particle enter perpendicular to both with velocity E by B, then in that particular case, the net force on the charge particle, that will come to zero, and the particle will move with constant velocity without changing its path. Clear to all of you? Cyclotron. Cyclotron, that is the device which one is used to accelerate the charge particle, right? And see here, it works on the principle which we discussed in the previous theories. One thing, when any charge particle enter in the magnetic field with velocity v perpendicular to the field, then it executes circular motion. And radius of the circular path that proportional to its momentum. And second thing we discussed, during its circular motion, the angular frequency, or we can say the frequency, that remains constant. On this particular principle, this device is developed. Okay. Two scientists named Lawrence and Livingston developed this particular device to carry out the study related to the nuclear structure, right? See, this one is the schematic diagram, and here the three-dimensional view that is given to you. You have to draw this particular schematic diagram in exam. This one is for understanding only. Okay. So let's first understand the construction of this one. So this entire system is placed in evacuated chamber. So in evacuated chamber, two magnetic poles are there. These are electromagnets with the help of which the uniform magnetic field is produced in that particular chamber. Now, between these two poles of the magnets, there is a box in the shape of D. So, these two boxes are known as dees because their shape, that is like letter D, and these are hollow dees. એટલે આ કેવું હોય, આપણે થાળી લઈએ ને જમવાની, બે થાળીને એકબીજાની ઉપર આમ ઊંધી છત્તી ગોઠવી દઈએ, પછી એને ડાયમેટ્રિકલી કટ કરી અને થોડીક એકબીજાથી દૂર કરી દઈએ, તો બે ઓપોઝિટ ડીઝ સામ સામે ગોઠવાયેલા હોય એવું થઈ જાય. અને આમ પાછા આ ડીઝ શેપના જે ડબ્બા કહીએ આપણે, એ ટાઈપની જે રચના થઈ આખી, એ હોલો હોય. ખ્યાલ આવ્યો આખી રચનામાં બેટા? ઓકે. So now here from the center of these D's, a charge particle is entered in the uniform magnetic field. So velocity of the charge particle, that is in the horizontal direction in the plane of the D's, and the magnetic field, that is in the vertical direction perpendicular to the plane of D's. So this particular charge particle will now execute circular motion. Now see here, across these Ds, the oscillator is connected. Oscillator, that is the AC source. So AC source for which the positive, negative potentials are continuously changing. So here, when across these two Ds, oscillator means AC source is connected, then continuously the D's becomes positive, negative, positive, negative, positive, negative. And here the frequency of the oscillator is kept exactly equal to frequency of the revolution of this charged particle. So now see here what happens when this charged particle start circular motion in the magnetic field. See, from this position it start, and suppose it reaches here. As soon as it reaches at the diameter of the D, now this is suppose positively charged particle. So this particular D becomes negative and this becomes positive. So this negative potential will attract this positively charged particle and this positive potential will repel it. So charged particle was moving like this. As soon as it reaches at the diameter of the D, the force acts on it due to these potentials. Now during the motion, if force act on the particle, then its momentum will increase. So if momentum increases, then we already discussed this thing, the radius of the circular path will also increase because R proportional to P. So your charge particle, now it is moving on the circular path with increasing radius. Now, as soon as it reaches at the diameter, this particular D becomes positive and this becomes negative. So again during the motion, when it completes the half revolution, force acts on it. Again its momentum increases, so radius also increases. So inside the opposite D, again it executes the motion on the circular path with increased radius. And when again half revolution is completed, this becomes positive, this becomes negative, and this process is continue. So our charge particle is continuously moving with increasing momentum, with increasing radius. And finally, when it becomes highly energetic and is revolving, remaining very close to the wall of the D's, then using this deflection plate, external magnetic field is applied on it and its path of the motion is changed and it is taken out from the exit port. Now this particular charge particle, when it comes out from the exit port, that is with high energy, or we can say it is highly energetic. And this particular highly energetic charge particle is bombarded on the crystals, or we can say samples, for which we want to carry out the study of nuclear structure. This particular device is used for ion implantation in medical line. It is used to destroy the cancerous cells by bombarding these type of highly energetic particles on the cancer cells. Okay, and these are also used to develop artificial radioactive elements. And here we can write the radius of the circular path, that is mv upon qb, which we derived already. Now frequency, that is qb upon 2 pi m. Here the frequency that is called cyclotron frequency. So in suffix c is written. From this one you can write the period of the revolution, that is 2 pi m upon qb. From this equation of the radius you can write velocity v, that is qbr upon m. So you can prepare the equation for the kinetic energy also, that is half mv square equal to q square b square r square upon 2m. Clear to all of you? Example 4.4. A cyclotron's oscillator frequency is 10 megahertz. What should be the operating magnetic field for accelerating protons if the radius of its dees is 60 centimeter? What is the kinetic energy in MeV of the proton beam produced by the accelerator? Charge, that is 1.6 into 10 raised to minus 19 coulomb. Mass of proton, that is 1.67 into 10 raised to minus 27 kilogram. 1 MeV, that is 1.6 into 10 raised to minus 13 joule. Now see the cyclotron frequency, that is 10 megahertz. So that is 10 into 10 raised to 6 means 10 raised to 7 hertz. Radius of the dees, that is 60 centimeter. So we can consider it as the maximum radius of the charged particle during its revolution, that is 0.6 meter. Charge of the proton 1.6 into 10 raised to minus 19 coulomb. Mass of proton, that is 1.67 into 10 raised to minus 27 kilogram. Okay. Now the cyclotron frequency, that is qb upon 2 pi m. Q, that is the charge of particle, so for proton E, and mass of proton, that is mp. So first of all we can calculate magnetic field from this equation. So we can write B, that is equal to 2 pi mp upon E into Fc. So operating magnetic field for accelerating proton, that can be calculated now. 2 pi 3.14, mass of proton 1.67 into 10 raised to minus 27 upon E, that is 1.6 into 10 raised to minus 19, Fc, that is 10 raised to 7. Now solve this one, you will get the magnetic field B. Now we have the equation for speed, that is qbr upon m. Okay, but qb by m, that we can write 2 pi fc. So v, that is equal to 2 pi fc into r. 2 pi, that is 3.14, fc, that is 10 raised to 7, r, that is 0.6. Solve this one, you will get speed of it. So now we can calculate the energy of proton. So that is half mv square. So half mass of proton into speed square. So here substitute the value of speed which we calculated here. Solve it. You will get answer in terms of joule. Then divide it by 1.6 into 10 raised to minus 19. You will get answer in electron volt. Or divide this answer in joule by 1.6 into 10 raised to minus 13. Directly you will get answer in MeV. Clear to all of you?
Yes, sir.
Now the next topic, that is magnetic field due to a current element, Biot-Savart law. Okay. See, scientist Orsted represented this thing experimentally. When current is passed through any conductor, the magnetic field is produced in the surrounding of it. And how this magnetic field is arranged, that also he represented. But what is the magnitude of that particular magnetic field? And mathematically, how one can represent the direction of the magnetic field at a particular point. So he was not able to represent all these things. So then after, two scientists, Biot-Savart, represented the relationship between the current and the magnetic field produced by it. See, this Biot-Savart law, that is the experimental observations. With the help of thousands of experimental observations, these two scientists represented the equation with the help of which one can calculate the magnitude of the magnetic field, and one can fix the direction of it at a particular point. And then equation itself is called Biot-Savart law. See here, suppose as shown in this particular figure, we consider a conductor carrying current I with arbitrary shape. Now, here we consider infinitesimal small current element IDL as shown in the figure. Now, due to this particular current element IDL, the magnetic field produced at point P having position vector r with respect to the current element, that we want to find. Okay. Here suppose the angle between the current element and the position of the point, that is theta. So Biot-Savart represented the equation, the magnetic field produced at point P due to this current element IDL, that is given by the equation mu0 upon 4 pi I dl cross r caret upon r square, where r caret, that is the unit vector in the direction of the position vector of that point. You have to remember this equation. There is no derivation of this one theoretical, because this one is deduced from experimental observations. So you can rewrite this equation as mu0 upon 4 pi I dl cross r upon r cube. Here unit vector r caret is replaced by vector upon its magnitude. Now magnitude wise you can write the equation of magnetic field, that is mu0 upon 4 pi I dl sine theta upon r square. And here we can fix the direction of the magnetic field B at point P using right-handed screw rule. It will be perpendicular to both the current element and the position vector. And specifically in this our case, the magnetic field at point P, that is perpendicular to the plane of paper and going inside. Here, this constant mu0 upon 4 pi, that is equal to 10 raised to minus 7. So mu 0, that is 4 pi into 10 raised to minus 7 Tesla meter per ampere, and this mu 0, that is called permeability of free space. It is the measure of the response to the magnetic field by the free space, just like the constant which we discussed in the electrostatics, permittivity of free space. Like that, this is the constant here in magnetic field, that is permeability of free space. So in magnetism, we use this constant. Now, this one is the magnetic field due to infinitesimal small current element. Now, for each and every small current element considered for this conductor, the magnetic field at P is calculated, and then after, if we take the vector summation of all those fields, then we will get the resultant magnetic field at point P. And for that, we have to take integration of this particular equation over the given conductor. Clear to all of you? Now, there is the relationship between permittivity of free space, permeability of free space, and the speed of light in vacuum. See how these three are associated with each other. Suppose we take the product of mu 0 epsilon 0. So mu 0 epsilon 0. Now here multiply and divide by 4 pi. So you can rewrite this one as mu 0 upon 4 pi into 4 pi epsilon 0. Now mu 0 upon 4 pi, its value, that is 10 raised to minus 7. 4 pi epsilon 0, that is 1 upon k, so that is 1 upon 9 into 10 raised to 9. So resultantly you will get mu 0 epsilon 0, that is 1 upon 9 into 10 raised to 16. But 9 into 10 raised to 16, that you can write as 3 into 10 raised to 8 whole square. But 3 into 10 raised to 8, that is the speed of light in vacuum. So we can write mu 0 epsilon 0, that is equal to 1 upon c square. So we can write c, that is equal to 1 upon under root mu 0 epsilon 0. Related to this one, the questions were asked in NEET and G both. Here see, if you take the unit of mu 0 and epsilon 0, and if you solve it, then you will get the resultant unit, that is meter per second. If you take the dimensional formula of mu 0 and epsilon 0 here in this equation, and if you solve it, then resultant dimensional formula obtained will be L1 T minus 1. Okay. So this one is the relationship. Clear?